Hi, how's it going? Hope you're well. So in this video, I'm going to add a cube map to the environment. In other words, we have our scene, there's a plane on the ground, we have our camera, we have a bunch of skulls and a humanoid character, okay, but I want to wrap this whole thing up in a sky, basically. So if you can imagine just I'm not good at drawing, just a virtual sky around the whole scene. That's the idea. Now, the way a cube map works is, well, we have two-dimensional textures, and the way we sample from a two-dimensional texture is we input a vec2, sorry. Just put this up. So we have something like -1 at the top, 1 at the bottom, -1 on the left, and x equals 1 on the right, and a vec2 in that range will sample some sort of point, or something like that. Could be between 0 and 1, doesn't matter. So, as for the cube map, well, the cube map is basically a three-dimensional cube. It's not really a three-dimensional cube, it's just 6 sides. And then when we sample from it, we input a vec3, which is interpreted as a direction vector. And then the program does a little virtual ray trace and says, well, if this position was coming from the origin and the cube was a unit length, so a length of 1 in each dimension, which face would it hit and which point on that face would it hit? And that's basically how cube maps work. They're 6 images. They are sampled with a 3D vector. Now, this coding session is going to be quite long, and for that reason I want to sit down and have a talk about basically how it's going to work. We are going to have 2 render passes. The first one will be the sky, and the sky render pass will basically draw a quad which covers the screen. However, every point on that quad is going to be sampled from a cube map. So in other words, we cover the whole screen with our vision of the background. And then we take that, and on top of that, we then run a standard render pass. And the standard render pass will retain the color buffer from before. And in addition to the sky, it will render basically the background. So anything that was there will be rendered on top of the sky, which was already drawn in the previous render pass. So that's one reason that this is going to be a long session, is because we're basically going to have to create 2 independent render passes. Part of that is we're going to, well, part of it's already done for us. I've done that for the start point. Basically taking the pipeline construction functions and turning them into a class which builds pipelines, like a factory class, so we can make as many of those as we want. But then there's just a whole lot of other stuff. Now, one of the other things is, how do we actually make the cube map texture? So before, the way this works is we'd take a file name and we'd load that, and that would be an array of pixels. And then we would take that and copy it over to a staging buffer. And that staging buffer is basically a CPU visible buffer that we can mem copy to in C. And then we take that, and we also do some other things. We do image layout transitions and things, but basically we have an image, and that starts in an undefined layout. We transition it into a copy destination layout, and then we perform the copy operation and then transition it into a color attachment layout or something like that. So there's a bunch of extra steps there. But basically, we go load a file, send it to a buffer that we can see on the CPU, and then do submit internal work to send that to an image, create all of the stuff that we need to create. Okay, so The way this is now going to work is, of course, we're going to have 6 images. So we'll have a whole bunch of these file names, 6 of them, in fact, and we'll take those and we'll copy that onto a staging buffer. But I can't see any reason why we would need a single staging buffer. I mean, we're loading 6 images, so why not have a whole staging buffer, which is really big, and then copy to regions of that staging buffer. So by the time we finish the memory copy, we should have all 6 regions of the staging buffer filled up with the image data. Then we have the image, and the way the image goes is it's actually a 2-dimensional image, but it's done with array layers. So we have 6 array layers. I'm just writing 3 because 6 would be too much. You get the point. So we have image layer 0, 1, 2, and so on. And this image is created with a special flag set. It's the cube compatible flag. Anyway, cube compatible. And we can actually get away with a single copy operation because in Vulkan, when you specify copying from a buffer to an image, you specify how much of the buffer you're copying, how many layers you're copying to, and you also specify the size in pixels of each layer. And the copy operation is smart enough to figure out how to send that data to the individual layers. So, I mean, pretty much that's it. What we then do is we've got all these images have been copied to, these layers within the one image, sorry, and then we create an image view. And when we create an image view, the type of image view that we create is a cube image view. So long story short, then on the shader side, we declare that we're getting a cube sampler. Then the shader gets in this image, which is created with cube compatible, and the image view is of a cube, and the image itself has 6 images. It knows how to put that together. Now, as always, the devil is in the details, and this actually took me quite a bit of fiddling around, which really bred a strong appreciation for validation layers. They're so useful, the error messages. But anyway, this is just, like I said, it's a long session, so I just wanted to give a big picture overview of what's happening, because a lot of it will be retreading the same ground. But anyway, yeah, let's hop in and have a look at the code. Okay, so like I said, this is going to be a long session, but you know, the only way to do it is to do it. So let's do it. The first step is, going to keep it nice and small, we'll just go to the config file and see here we've declared some mesh types. I'm also going to declare some pipeline types. Okay, great. Yeah, so we're going to be constructing 2 pipelines. Now, it's also a good idea to go through and browse the code because I have modified things a little bit. The big thing that I did is if we go to the pipeline file, I've now wrapped this all up in a pipeline builder class. And the way this works is we basically need to set various flags, specify various options, and then call build, and that will make a pipeline. So I won't go through this now. I'll be going through it plenty when I modify it, but if we open up the engine and have a look at the pipeline function, here we go. Here's how it works. We make the builder, and then we specify a bunch of options, all of this stuff, and then we just go ahead and build. Okay, so with that in mind, the next thing we need to do is go to the engine, and some of these resources are going to be duplicated. So for instance, pipeline, we're going to have multiple pipelines. I'm going to wrap this up in an unordered map where the key is that pipeline type enum, and the value is the pipeline. And std unordered maps are so useful. They're probably my favorite new feature at the moment, and I mean new in the sense that I just discovered them, but yeah, I don't know why it inserts all these spaces, but the point is all of these resources I'm going to generalize. So now we'll have pipelines. Does it matter? No, it doesn't. Okay, right, so then we have these descriptors. And, well, if we have multiple render passes, they will be taking in multiple different things. So that will be multiplied as well. But what won't be multiplied is the pools, the allocators. Because a pool can allocate multiple different sorts of sets. I mean, what would be the benefit of it if it could just allocate one? I mean, there could be some benefit, but anyway, we're going to multiply that as well. Okay, and then the last thing I'm going to do just later on to speed up deletion and things, I'm going to make just a vector of all the different pipeline types. Okay, so there we have it. At this point, I'm just going to pop back into the engine and we should see a whole bunch of errors. That's fine. I'm just going to make sure that this is working as I expect right now. So I'll just set this up as if we had one pipeline, and then I'll give it a spin. Okay, there we go. So later on I will improve this, but for the time being I'm just pretending that I've got one pipeline, because I do just have one pipeline, but anywhere where it was asking for a resource, it was getting an unordered map, and that's not great because it's not a single resource, so I just access the thing that's there. So it's a good idea just to give this a spin and check that we haven't broken anything too severely. Okay, good. So as we can see, it's working as we'd expect, no problem. So we'll close that down. And then the next thing I want to do is I want to start working on the swap chain frame, because I want the frame also to be able to work with multiple, what am I saying? Multiple pipelines. Okay. So because we're going to be working with multiple pipelines, I'm actually going to be working with multiple frame buffers. So we'll have an unordered map here as well. For instance, the way this is going to go is when we're just drawing the sky, we don't need to do a depth test. So the frame buffer will just have the swap chain as its attachment. But then when we go to do the standard render pass, we're going to need the swap chain and the depth buffer. And then also, right down the bottom here, this descriptor set is going to need to be, we're going to have multiple of them. Okay, now also while I'm at it, I'll fix the rest of this up in a second, but while I am at it, if we look at this right descriptor set, this goes ahead and updates the descriptor sets. But then if we look at these individual bits, none of this is constant. None of this is dynamic. So this right info has a destination set. That's fixed. If I change the underlying object positions that I'm writing, it's still coming from that descriptor set. It's still, that's where I want to write it. All of this stuff is all constant. So what I'm going to do is save myself a bit of time by writing to this stuff once and then performing those operations. So in order to do that, I'm just going to go right back here and I'm going to say, okay, I'm going to record the write operations. In addition to this vector of write operations, I'm also going to make a function which, will record those write operations. And what that's basically going to do is it's this bit here. Be a little weird and duplicate those functions. Okay, cool. So we'll go descriptor set. And I'll neaten this up in a little bit, but for now, I'm just going to get it working. So all I really need to specify for both of these write operations is really which descriptor set we're writing to. And then instead of performing this operation, I will go ahead and set up the vector of those. Okay, cool. So just clear this up. So then when it comes time to actually write these, we can just pass in the write ops. Those are saved. And if we hover over, it says that this first argument just has to be some sort of array proxy. So it's either an object or it's something which has a length that we can loop through. And this should handle it. Then down here, I just need to destroy the specific frame buffer. There we go. Now I'll head back to the engine and check that this has been set up correctly. Just browsing through that, that looks fine. So we go back to the engine and we should have a bunch of errors. That's totally fine. Okay, bind descriptor sets. Well, the question is, which descriptor set are we binding? We're going to bind to the graphics pipeline, to this specific layout, and the descriptor set we're going to bind is the standard set. Why not? We haven't set anything else up. Then above, we say, okay, which frame buffer is the render pass going to work with? Let's take the, again, we'll take the standard frame buffer. I know it's getting a little long, but it should work. And then let's double checking. Okay, so up here we want to set the standard descriptor set. And then while we're at it, we've just set the descriptor set. Let's go ahead and record those write operations. So we do that once, and then that info is reused. So let's give that a go. Totally fine. I'm always expecting errors when I set this up. Okay, so that is frame buffer, line 44, no problem. Of course, we need to say the standard frame buffer is this one here. Okay, there we go. It's looking good. Performance seems to have gone up a little bit. Hard to measure because I'm recording this at the same time. But anyway, I mean, what does it matter? 3,900 frames per second, 3,800 frames per second, what's the difference? Now, it's also important to check whether we're getting any validation errors. We don't seem to be at the moment. We close and we do get a validation error. Okay, no problem. So that is saying that the shader module has not been destroyed. Okay, no problem. So that is happening in the pipeline builder. So we'll just go off to that pipeline builder. And now this is a little bit subtle. I won't bring the program up again, but If we go down to this bit where we reset the shader modules, you'll see that yes, we are destroying the shader modules, but we're not clearing the reference. Does that make sense? So what I'm going to do is I'm going to say, okay, we'll set the vertex shader to the null pointer, and then we'll do the same with the fragment shader. And then Vulkan should see that this thing has been set to nothing. And I'll do the same thing down here. So when we specify a vertex shader, we should also, as well as destroying the old one, we should nullify it. Okay, now let's give this a go and confirm that we are getting what we expect. Oh, wait a second. Okay, maybe it's not even that. I'm just trying to remember how I wrote this. So that's fine, that works. It's a good idea to nullify it. But I think we should also have a destructor. And the benefit, so what we're doing, sorry, this is all over the place, but it is a large code base. So what we're doing is when we make the pipeline, we've got this pipeline builder object, and this is a local variable. So when the function ends, that pipeline will be destroyed automatically. But we're not specifying, we're using the default destructor, which does not destroy underlying objects. So what we need to do is specify a destructor, which will destroy those objects. So I'll just go back and say, okay, here's the destructor, and I've got this function down below which basically destroys everything, so let's call it. There we go. Let's give that a go. Okay, we've got our program, and now moment of truth. Excellent, no errors. Good to see. You know how Vulkan is. If you don't handle an error, it will come back. Okay. So I'm pretty happy with that. At this point, I'm going to write the shader, and then that will inform the rest of what I'm doing. So I'll just go to the shaders and basically copy these. Okay, now just grab everything just to have some code. Why not? So for the vertex shader, I'm going to take in a uniform, but I need the, I need it to be the fundamental vectors of the camera. So I'll call that camera vectors. Now, of course, the vectors of a camera, we have forwards, right, and up. Of course, these things are vec3s, but the issue is when you're passing in data, you have to worry about data struct alignment. It's messy. It's so messy. So I'm just going to make life a little easier for myself. This is my one big revelation that I came to recently, is just make it easy. Okay, so I'm just going to store it as vec4, even though I'm not using that last component. Totally fine. And we don't need a storage buffer. We're just doing one object. As far as stuff that we take in absolutely nothing. I'm going to hard code everything. But as far as what we put out, we're going to put out basically the direction that pixel is looking in. So it's the vec3 from the camera's direction, from the camera's origin through the screen, if that makes sense, out into the world. Okay, now I'm also going to need a bunch of screen coordinates, and I'm just going to paste this in. But basically I'm going to hard code it. Here we have x -1 being on the left of the screen, y -1 being at the top of the screen. So this would be the top left, and then we go bottom left, bottom right, and so on. And this is basically just setting up two triangles. It's a screen quad. We know what this is. Okay, so no problem. Now I'm just gonna go through this. So we'll have, just gonna grab the position that this current fragment is on the screen. Okay, great. And then I'll leave this other stuff for now. So what I'm going to do is get that position, insert a Z of 0, so it's at the screen depth. And yeah, that's a standard thing. And then I need to get the forwards vector. And the forwards vector is going to be a sum, a vector sum. Okay, now the, yeah, so we'll just, actually I'm having second thoughts here. Let's subtract both. Sorry, I've just blanked for a second. So if you imagine that you're sitting at the origin and you're looking in the positive x-axis, then your right-hand side is actually in the negative y-axis. And so to correct for that, I'm going to subtract. I could be wrong here. Correct myself. I'm just going to add for now. It's fine. Right. But it should be subtracting. Side note. It's just so that this matches up with my previous video that I flashed at the start. Anyway, I'm going off on a tangent. But definitely here we need to reverse this, because we would think about like z equals 1 being straight up. But then in Vulkan, the convention is that negative y is up, not positive y. And so for that reason, I'm going to subtract. Hopefully that makes sense. Well, what I need to do is, first of all, I need to normalize this. And then I need to extract it to a vec3. So I'll get the x, y, z components. Okay, excellent. I think that's fine. Yeah. So let's go over to the fragment shader. I'll get the old fragment shader. I just find it useful to have old code. I don't know. Okay, so for the input, I'll take the output. And then here I'll have a sampler, but it will be a cube sampler. Okay. I don't need any of this. That's fine. And all of this stuff can go. I'm just doing a simple sample. So again, as the texture coordinate that I'm using to sample, I'll just input that vec3, and the understanding there will be that it's a Cubemap sample. Okay, so with both of my new shaders written, I can go ahead and compile them. And I am noticing it's getting a little cringe that I keep using this batch file, but we'll see. I'll maybe update that in future. But anyway, it's done its thing, and there have been no errors, and I can see the, whoops, where are they? Oh, of course. What am I thinking? What am I thinking? I need to update the batch file. Like I said, a little cringe that I'm still doing this, but anyway. There, we've got it. Okay. Give that another spin. Again, okay, everything's compiled. There's no errors. I can see my SpearV files. Okay, excellent. Good. So now we have to consume the data and send it over, if that makes sense. So I'll just go over to the, where is it? The frame header. We can close this down. We're done with this. Okay, so we have this UBO, and I'm gonna rename this. I'll call this, whoops, camera matrices, because that's literally what it is. And then we'll have camera vectors. Okay, excellent. So yeah, there it is. Those are the two structs that I'm going to be using. Now, just checking through all this stuff. Yeah, this is all looking fine. I think the issue down here is the resources. So I'm going to, again, neaten things up a little bit. So we'll have the camera matrices struct, which I'm going to call camera matrix data. And then we'll have the camera matrix buffer. Little big, but there we have it. And then in addition to that, I'll have all of that again, but with vectors. Okay. So now I'm going to have a whole bunch of different descriptors. So down here, and I'm going to start doing this in order of how the data is sent. So I'll have camera vector descriptor. Just like that. Okay, so those are the three descriptors for the three resources, and then, yeah, we have a bunch of different descriptor sets. Okay, so we'll then go to the source file, and we'll have a bunch of errors. That's totally fine. Totally fine. We'll just have to go through all the steps here. Okay, now I'll just do all of this again for the vectors. Okay, so obviously at this point we don't need to re-specify all this. It's not going to change. And we also don't need to re-specify the usage because that's not going to change either. Okay, cool. So we've got those resources set up. We then just need to go down and create the descriptors. Okay, that should be fine. Cool. So we've got the descriptors, and then we'll just go down to, yeah, this write info. And again, I'm gonna generalize this, gonna improve it. So I'm gonna call this, yeah, so it's the operation of writing the camera vector data. Righty, we are going to write to the sky pipeline. This is all fine. Yeah, uniform buffer, totally fine. Right, and then this will be the camera matrix. And again, that's totally fine. Ooh. We should not be doing that. Well, it doesn't hurt, it's just we don't have to. All right, and then this will be, I'll call this the SSBO write. Now at the moment, I won't perform that other write. I'll just do these ones, okay. And then later on, when we have everything all working together, we'll do that. But I'll just, oh, good idea. Okay, so just go through the steps here. So make sure we're destroying everything. Yeah, there are nicer ways to do it. This is fine for now. I feel like code has to reach a certain level of complexity before I refactor it. Otherwise, it's over-engineering. Okay, totally fine. What do we have here? Camera data is not a member of... Oh, right. Okay, so engine 287. No problem. As I hope you can see, it's really just an exercise in renaming things at this point. Fingers crossed. Let's see how that goes. Okay, everything's working. I'll just verify there are no validation errors. Okay, excellent. And we can close it down. And similarly, no errors. Okay, great. So now what I'm going to do is I'm going to build the sky pipeline. Okay, so what I'm going to do is I'm going to basically grab all of this and redo it. Okay, now as for the vertex format, we basically are passing in no vertices, so we won't call that line. Then for the shaders, that will be again sky vertex and sky fragment. Swap chain extent, perfectly fine. Depth attachment, we're not going to use it, and just to be really clear about that, I'm going to call clear depth attachment, and what that will do is basically just set the, I believe it was already being called in the constructor, but it will set the flags just to make sure that no depth attachment is being used in the render pass. Then for the frame layout, it's going to need to be the sky layout. But wait a second, we haven't allocated that, so no problem. Let's put a pin in that for the moment and pop over to the frame set layouts. Here we go. Okay, so what I'm going to do is before I make the standard layout, I'm going to make the sky layout. Now if we were to look at these layouts, it would be basically the sky layout would just have the UBO. It wouldn't have the shader storage buffer object. But then if we look at this again, we can see that these are actually the same thing. I mean, they're both uniform buffers. They're both vertex 0. They're both attachment 0 and all of that. So I'm just going to actually get rid of this. So the first time we run this, we just have one thing, and that will go to the sky frame layout. And then the second time we run this, we'll add in that shader storage buffer object. There we go. And then when we make the mesh layout, well, both of these are going to use a combined image sampler. It's a sampler 2D in the standard frame. It's a sampler cube in the sky frame, but they are both, does that make sense? They're both combined image samplers. So I can actually reuse the same specification for both perfectly fine. And if I was really clever about it, I wouldn't create two of these, but that's fine. Hey, this is how the sausage gets made. So, I mean, there are heaps of different ways to do this, as with everything. So then, hopefully, this should now be working. And then here I'm going to add this color attachment. There we have it. And I'm going to read back all of this stuff. Okay, and now some of this stuff is going to be used in the frame creation. So we've got the, what am I thinking? We've got the pipelines built. Now let's have a look at the frames. So if we look at this make frame buffers, I'm actually going to modify this a little bit. So I'm going to change the frame buffer input so that it takes all of the render passes. And then I'm going to have a look at that make frame buffers function. So we'll just go over to the frame buffer input. Okay, so there's no errors. And then we'll have a look at the make frame buffers function. So all of this stuff is making a single frame buffer. I'm actually going to duplicate it and make 2 frame buffers. So the first time I'm going to make the standard frame buffer, which just has the color buffer. That's it. And then as its render pass, that will be the sky render pass. And I will save that into the sky frame buffer. And just to make it a little clearer, I'll specify which one I'm making. Okay, excellent. So then down below, good point. Did I miss something? Super quickly. Yeah, whoops, I'm redeclaring bindings again. I don't need that at all. I felt like I missed something. Okay, so back to the frame buffer stuff. Because again, we don't want to, we don't want to redeclare the attachments. And we can actually be really clever about it and just add in that depth attachment. Okay, just double checking. Right, so again, we don't need to redeclare this frame buffer info. Just double checking, so we don't need to set the flags again. And we don't need to set all this width and height. Okay, I think that's all right. Now let's go back. So we've made the... Okay, so this function does its thing, populates the frame buffers, and finalize setup. What does that do? Command pool should be totally fine. Make frame resources. Now here we're going to run into trouble because we're going to allocate a descriptor set for the frame. But every frame is going to have 2 descriptors, so we'll go sky. But then we're going to run into trouble, and the reason is we can totally have a descriptor pool that allocates a whole bunch of different descriptor sets, but that'll only allocate like 3 descriptor sets, for instance. So we just need to go double because we're doing 2 per frame. I just realized I've been a little naughty because, well, if we look at the descriptor set associated with the sky pipeline, we have actually allocated a descriptor set which could write to both, it could include both a uniform buffer and a storage buffer, which isn't all that's being used. However, by doing that anyway, we have reduced the number of descriptor pools. So it's totally up to you if you want to make a separate descriptor pool for each pipeline and be more specific about which one each one is binding. I'm just going to go with this because it doesn't break anything as far as I can tell. Alright, so it's a good idea, I guess. I think I've covered all my bases. I'll get back to this in a second, but I think it's a good idea just to run this and confirm that we're not getting into any errors. Well, look, we are. Okay, what's up? Output redefinition, no problem. Engine 177. Yeah, I think I see this. That's what it is. That's what programming is. It's debugging. Error. Ooh, not good. Okay, so we were making a render pass. Oh, yep, I remember what this is now. Okay, there we are. Alright, so the issue is that I'm making a render pass for the sky, which just has a color attachment. It doesn't have a depth stencil attachment. So this attachments vector would just have one thing in it, not 2. So we can pretty easily check that. We can go basically querying, do we have a depth stencil attachment? And there are nicer ways to do this in future, but This is just the intellectual scotch tape that I'm going to put on this for now. Okay, that should be fine. Okay, great, that is working. We can close that down. Ha ha ha. Okay, excellent. What do we have? Pipeline layout. Ah, right, okay. I think it's time to finish off the deletion stuff. So we just go to the engine, down the bottom, cleaning things up. Okay, so now I'm going to do this. Give that a go. See if that's covered everything. Almost everything. Frame buffer. Okay, no problem. I think frame buffer is handled by the frame. Alright, give that a go. Excellent. Nice. Nice and clean. Okay, no errors. Great. So, like I said, we're just going to shift it a little bit at a time and keep checking it. Check we're not breaking anything. So, oh jeez. Sometimes if I scroll too quickly through the code, it's just so disorienting. Okay, that's fine. That is fine. Okay, prepare frame. Cool. So what I'm going to do is basically just prepare the, what am I thinking? The camera vectors. Okay, cool. So, going forwards, so that's 1 in the x-axis and nothing else. And then going right is -1 in the y-axis. It's important to make sure that I haven't got any other numbers here because that'll really mess up the sampling. And then up is just 1 in the z-axis. And yeah, it's a little weird that I'm defining these and then immediately copying them over. I think at the time when I first wrote this code, it made it feel more readable. I'll probably neaten it up. Well, I'll definitely neaten it up when I make an actual dynamic camera object. But anyway. Okay, so at this point we've written everything in, and I'm also going to go back to the frame and set it up so that we are now also performing the vector write operation. So for those of you keeping score at home, we now have the camera's fundamental vectors, matrix, and storage buffer written in. This stuff is everything we need to draw the 3D stuff, and we're edging towards getting that stuff on the screen. So, where was I? Just give this another shot. Check that it's running with no errors. Ooh, not great. So that is happening in update descriptor sets, and it's saying descriptor writes 0 basically has the wrong range. Range is 192, which we only need to write 48 bytes. It's trying to write 192. That's probably caused by it's caused by this. So when we made the vector descriptor, we passed in the wrong size. That should now be set at 48 bytes. Okay, good. No errors. No errors. Excellent. Happy to see that. Now, the next step is we would go to the engine and we would take the functions and split them out so that we have a function to render the sky and a function to render the scene. But before I go on to that, I'm going to work on the image stuff. Just close all of this down. Okay, so at the moment I've got this image file, which includes both the image functions and the image class, and I'm just going to split this all up. So I'm going to make a separate texture class, and while I'm at it, I'm going to make a Cubemap file. Okay, so in this header file, we should just have the class definition. We don't need this stuff here. And I guess we'll need to include okay, so there we have it. That's the class definition. And then this stuff down here, we don't need this. Or I should say rather the class declaration. Of course, the definition is in the source file. So great. And similarly, I'll just go to the image header and remove the class declaration. Okay, so similarly, I will just go to the texture and we just need this texture header. We will only be defining, implementing stb image in the texture folder. That's where image folder. That's where I decided to do it. Right, so this we need. We don't need single time commands because jobs are submitted in the image file. But yeah, we'll just have the class stuff here. So that is fine. All of this is fine. Yep. And then, yep, that's fine. And then all this other stuff we can get rid of. Okay, and I'll leave the Cubemap for the time being because I just want to check that this is running. So I'll go back to the engine and make sure that I guess let's keep image there. There we go, and just give that a shot. Check that it's working. Oh, right. Of course, I forgot we need to remove all the class functions. Okay, give that a shot. Alrighty, that's working and we can close it down. No error. Perfect. Okay, now I'm going to have a look at making the Cubemap. So just to see where we are, I have this texture folder, and in this texture I also have a bunch of these files. And yeah, I mean, these represent the sides of an image. So what I'll do is I'll just grab everything from the texture and put it in the Cubemap. For now. And I'll just go through the game of renaming everything. Okay, so one thing I'm going to need to change, instead of one file name, we're going to need a whole bunch of them. And similarly, for the sets of pixels, after we load them, we're going to have 6 sets of pixels. Okay, but this will make issues. I'll address that in a second. I'll just quickly go over to the Cubemap. Let's change that. And then similarly, well, input needs to be a vector as well. So I'll just change that around. We'll go to around this time things start to get a little fiddly because we're just running around changing a whole bunch of little details. But we'll have to go, yeah, file name, that's fine, and then in the constructor we'll just, if we're making a regular texture, we only have one file name, so just grab the 0th thing and that should be fine. And then just pop over into make assets. And this is slightly dodgy, but I'll just specify that these are all vectors with one element. There we go. I think that's fine. Alrighty. So while I'm at it, I mean, this is looking ahead a little bit, but I'm just going to set this because, well, if we have 3 files, we want to declare 3 textures, 3 descriptor sets, but then in addition to that, we're also going to have the sky. So we'll need 1 more descriptor set to be allocated from that pool. But back to the stuff. So I'll just close that down. Yeah, texture is probably fine. Anyway, the rest of this is okay. So I'll just pop over and rename all of this stuff. We'll get to that in a second. Okay. Right, so what I'm going to do is I'm just going to write the Cubemap class as it should be operating, and then that will necessitate a bunch of changes in the texture stuff. But I think it's easier just to write what I intend to do first and then fix it up. So I'm just checking through, this is fine. Okay, so the first step is we want to load stuff, and the issue here with loading is we don't just want to do this once, we want to do this 6 times. So we'll say no problem. Yeah, so we're loading each of the 6 images. Okay, loading's fine. I'm happy with loading. Then we come back here and we want to create the image. So yeah, logical device, physical device, that's totally fine. I'm going to make another field and I'll propagate this change through later. But for now, I'll just declare it. So we'll have I'm going to set an integer being array count, the number of layers that I want to have, and in this case it'll be 6. We'll have the width and the height. This is all fine. This is all fine. Okay, but there's another thing that I want to set, and that is flags. And the one that I'm after is this cube compatible flag. So later on, we'll take this and we'll construct an image which is compatible with the cube. All right, so then the next bit, this is all fine. Make image memory. I then want to populate the image. So when it comes to populating the image, we have this buffer input, totally fine, totally fine. Now just before, because I'm going to reuse this, I'll just keep a track of how big the each individual image is. So I'll call that image size, and that will be width times height and 4 channels, just the same way as I've got down here, but then for the size of the staging buffer, that has 6 images, so it will be image size times 6. Okay, so we go ahead, we create the input, and then we fill it. I'm going to fill it 6 times. Okay, so as for this right location, I want to map starting at a certain region. If I take I and multiply it by, whoops, the image size, then of course the first time it'll be 0. But then the next time we'll start writing just after the location where all of the first image was written to. Yeah, and then as for the amount of data that we're writing image size worth of bytes. But yeah, then we go and we write pixels thing number I, image number I. The amount of stuff we're writing is image size. Okay. Now, I'm going to have to add some more parameters to these jobs. So again, we have a transition job working on the command buffer, Q image, that's fine. We want to transition it from an undefined layout to a transfer destination layout. And I just want to specify that I'm transitioning 6 image arrays. So remember that what we're doing is we're transitioning our image, which has 6 arrays. We're transitioning all 6 of those array layers. Okay, and then similarly with this copy job, again, command buffer, Q, perfectly fine. The only thing I want to specify is the array count. And yeah, okay, no problem, no problem. And then all the rest of this is fine. Okay, so I'll just close that down. And again, I'll get to fixing this up later. So we populate it, then we want to free the pixels, but of course there are 6 images, so we'll do the same stuff. We'll loop. Right, then we come to make the view. When we make the view, I'm going to need to specify a few other things. I'm going to need to specify the type of image view that I'm making and the number of array layers. Okay, that's fine. Alright, make the sampler and then the descriptor set. So I don't think this actually has to change. Just checking through. Yeah, no, this is fine. Yeah, that's fine. Because the image view's already been made, so that's the point at which we differentiate the different types of images. So then make the descriptor set. Again, that's perfectly fine. I mean, it just references an image view that's already been set up properly. Okay, cool. So now to propagating those changes through. So I'll go back to the image header. Totally fine. All right, so now we'll have the array count and the create flags. Then we have these jobs, and again we'll specify the array count there, and then for the copy job, again, the array count. Okay, so we have make image, that's fine, make image memory, perfectly fine, transition, yep, copy buffer. Right, okay, so now make image view. We need the view type and the array count. Find supported format, that's perfectly fine. Okay, cool. So just pop over to the source code and fix that up. Okay, so here where I say array layers, let's actually set that. But yeah, the rest of that should be fine. So make image is okay. Make image memory, totally fine. Okay, then we have this transition image layout. We just need to get the array count, the number of arrays which are being transitioned, number of layers. Okay, just checking through all the rest of this. Yep, source, destination. That's fine. Okay, so I'll just leave that one. Then we have this copy buffer to image. And then it's down here, this layer count. We need to set that. But yeah, the rest of this is totally fine. So again, I talked about this right at the start, but I do think it's super cool that all we need to do is specify that we're copying all of the buffer. And then where we're copying, we need to specify how many layers we're copying to and the size of each layer. And this function will work it out. It will copy everything over properly. Anyway, I think that's super cool. Right, now for this make image view. Okay, so now for the view type, we can actually just plug that in. And that should be it. So this will then create more issues, which I need to check. So I'll go to the texture and we'll see that it is complaining, but no problem. I can just go and fix that up. Just being extra careful with this, because what happens is if I don't set one of these things that I'm meant to set, it won't throw an error here on the IDE, but then it'll get an uninitialized value. So it'll get, instead of 1 for the array layers, it'll get some random number like -6,000, and it's annoying. Yeah. Yeah, so you need to set that to 1, and then similarly fingers crossed, eh? So we have that, and then make view, that's the other one. All right, so for the type, we'll go 2D, and then for the array count, we'll just say 1. That should be fine. But then there's another place where it doesn't quite like it, and that is, what is it? I think it's in the swap chain where we create the image views. There we are, right down the bottom. So similarly, the view type is 2-dimensional, 1 layer count. This is a lot of fun. This is a fun session. Okay, and then I think in the frame, we're also creating a depth texture. Yep, so we need the depth buffer view, but it's the same stuff, so. We have it. Fingers crossed. Let's just run this and see what happens. Okay. Ooh, right. That's what I was saying about like random things. It was saying, what was it saying? Out of range or something, like some weirdness. Here we go. Input format limits violation. Resource size exceeds allowable maximum size. So this is the number that we've got here for some sort of resource size. The maximum size is this one here, and what that comes from is uninitialized values. So we need to go image info array count and fix that at 1. That was for the image creation there. Okay. Hope we don't get that again. Okay, there we have it. No errors. Good. So hopefully you're getting the common theme today, which is we need to change a lot. And I don't like picking through errors. So what I'll do is continually run something, check that it's working. Yeah. But at a certain point, we are going to have to take a leap of faith with this. Okay, so the next thing I'm going to do is I'm going to create the Cubemap. So just pop back here and include that Cubemap. And then right down the bottom, I have the asset stuff. I'm going to go declare that. And then in the cleanup, I'll, of course, delete it. Right down here after I delete everything else. Okay, and now for the Cubemap creation. So just pop back. What a mess. Okay, so I'll just change things around. We do not need to change the command buffer. Perfectly fine. Q doesn't need to change either. Neither does any of this stuff, but what does need to change is the layout that this is going to be bound to. And descriptor pool, does that need to change? No, it doesn't. It does not need to change. And then I'll just pass this in. So it's just a lot of typing, but I'm just loading each of the 6 images. So there's my set of image file names. We load that in and create it. So I think, no, why not? Let's give it a go. Okay, what do we have here? Ooh, right. Okay, so I forgot to incorporate that flag. So we have that this is incompatible with image view 2D. Okay, if the image was not created with create cube compatible, so we say, wait a second, but I passed in the create cube compatible. What's going on here? Well, I forgot to incorporate that. Totally fine. So what I can do is just go to the image stuff, and where we go to create the image, I take the flags and I take it, or the that should be fine. There we go. Okay, cool. So that's working. Excellent. So again, what I did is I just took a bitwise OR between the create flags and the flags that I specified in my input chunk, and that will incorporate the cube compatible flag. All right, it's time to start taking that leap of faith. So if I pop back to the engine, I've got this record draw commands, and I'm going to split that into 2 functions. I'm going to have record draw commands sky and standard. So I'll go back and just go down here, and what I'm going to do is I'm going to begin the command buffer before this function begins. You'll see why in a second. So when we go to render, we do all of this stuff, then we come to record the draw commands. So again, we prepare the frame that sends everything over to the descriptor sets and stuff. Then we begin the command buffer. Then we have a series of other functions which will record to that command buffer. So that's the reason that we need to do the beginning and ending outside of the function. So the way this works is, first of all, we'll do the sky, and then we'll do the standard version. And I'm just going to focus on the sky right now. So we'll get the sky working, we'll get the standard version working, then we'll get them working together. Okay, so this will be much stripped back version of the original. So we'll of course be working on the sky pipe render pass, working with the sky pipeline, and then we'll have the clear color. So I'm just looking at my own code. All right, so we'll just be clearing the color, not the depth, because we're only binding the color buffer. So no problem, we've got that stuff set up. Let's double check in my own stuff.
we bind the sky pipeline. Just all of this stuff, all this standard stuff should be sky. Okay, prepare scene, we actually don't need that. Prepare scene would work with all the objects, but we're not drawing any objects, just that single texture. And I don't need this stuff. So what we'll do is we'll use that with our command buffer, setting it up for the sky pipeline layout. And then we'll draw. And then we'll end the render pass. I think I might have accidentally taken that out of the function along with the command buffer. There we go, end render pass, and then okay, so right now we should just see the sky. Fingers crossed. I don't know what's going to happen. Just so we don't get any errors, of course, we'll rename that. We'll look at that in a second, give it a shot, see what happens. There we have it. We are, in fact, seeing the sky. It's a bit funky. So, I mean, I guess we could do some operations to swizzle things around, but I'm just gonna do it by hand. So, just from memory, I think if we make 3 rotations, it'll fix everything. I think. Let's find out. I think that's fine. I mean, there's nothing precise going on here. You might want to just shuffle things around until it looks right. Not super satisfying, but yeah. Okay, cool. So that looks the right way around. So we've got the sky working. Close it, no errors. Okay, so now let's check that the scene is working. And I'm going to do these separately, like I said. Okay, scene's working. But then if we try to get them working together, as you can probably imagine, things don't quite go as expected. So we're overwriting the background. Now, of course, this should probably be clear why we're overwriting the background. I mean, what did we do when we rendered the sky? The first thing we did was, whoops. I mean, yeah, standard. First thing we did was reset with this clear color. So frustrating, because it feels like we're almost there. And I mean, I went through the difficulty of I actually had to read the docs. Shock horror. But here's how we're going to handle it. So it comes down to the pipeline builder. When we build the pipeline, we attach colors, or we attach things to the render pass, and we have options that we can set for the store operation, the load operation, initial layout, and things like that. So I'll give the abbreviated version, and that is, let's go to the pipeline builder. We'll give it a public function, which I'm going to call I'm just gonna handle this in a really sort of slapdash way, but why not? So I'll have a Boolean variable which stores whether we want this to be a fresh render pass or whether we want the render pass to build on top of a previous render pass. We'll just go ahead and store that somewhere, doesn't matter. And why not? We'll give it a default value. So for this specify overwrite, it'll pretty much do what you expect. It'll just set that Boolean. Okay, and then when it comes to, where are we? Making the stuff. So I'll just pop back to the engine. Yeah, so the first time it'll just be a fresh run, and the second time we want it to build on top of the existing color buffer, basically. Okay, so now things are going to get a little bit messy, but let's go for it. Okay, so I think it's this one here, this make render pass attachment. So we need to specify the load operation, the store operation, the initial layout, and I guess the final layout too. Let me just quickly check if there's anything else I need to change. No, I think the rest of that's all fine. Okay. Alrighty, okay, so we have this load op, which by default is just clearing the color buffer. If we set that, then we have more control over what the color buffer does when we bind it. So we still need to specify a clear color. We need to specify a clear value for every single thing that we have attached. But depending on the load op, it will either use that or ignore it. And then similarly, we'll have the store operation and the initial layout here. The reason for that is that when we acquire, when a render pass acquires an attachment, there's an implicit transition in the layout. So for that to happen, we need to get an initial and final layout. Okay, so then that looks fine. Now just pop back for this add color attachment, and I'll do the following. So first of all, we'll specify the load operation. By default, we don't care, which is, I mean, I guess it's similar to clear, but I mean, clearing the texture has some overhead, and we're already drawing over the whole screen with the sky, so I really don't care what I clear that with. And then if we're in overwrite mode, then we, instead of clearing the color buffer, we want to load what was previously in the color buffer. In other words, we want to preserve the contents of the color buffer for the next render pass. Then the store op will always be store. We will always store what's in there. Then for the initial layout, again, if we're coming in fresh, then it has to be undefined. But if we're writing over something, then it is present source, is the layout that we're writing from. And the final layout will always be present source. Okay. So then we can go ahead and set this up. We'll go, okay, set that up. That's perfectly fine. And then we'll go to the depth attachment, and it's going to hard code these. So when we load up the depth attachment, we'll always clear it. As for storing it, we don't care because we're not going to use it in another pass. And then for the initial layout, we'll go undefined. There we go. Okay, fingers crossed. Let's find out. Let's do it. Okay, there we go. I mean, we've got it. We've got the sky. Now there are some cosmetic differences we could make. We could bring the models closer, just like I flashed up at the beginning of this video. We could change the light direction and color, but I feel like those are fine. Those aren't particularly challenging. And I'm tired. It's been a long session. So I'll leave it there for now. But yes, I hope you enjoyed this session. I hope you feel more confident understanding render passes and resources and everything. And yeah, just hope you had a great time. And yeah, that'll be it for now. So have a good one. And by the way, if we're speculating on what I'm going to do next, I'm thinking that this loading time is pretty long, and that's just for loading one model. So imagine if we have a whole bunch of resources we need to load. So what I'm thinking about, what I want to work on next in this series is multi-threading the jobs which are going to take time. So multi-threading, submitting a bunch of texture load operations, model load operations and everything, and having a bunch of worker threads in the background to handle that, so that if we want to load up a really big scene, it doesn't take ages. Anyway, so that'll be it for now. Hope you had fun, and I'll see you again soon.